All right, so we are done with the content. So I gave you guys everything. So today I'm just like want to give you some tips how to study for the final exams and how to tackle the exam and how to get as much points as you can in the final exam. So first that I want to make sure that you will start now because so let's so now you only have, let's count today, Friday, Saturday, and Sunday. All right, so that's what I usually do, and that's my advice for you guys. But whatever strategy that you have and you are comfortable with, just go for it and do it. So, uh, so the final exam is on Wednesday. So here's our final exam. I usually leave the day before the exam for final revision. And I will tell you what I will do exactly in this day. And I revise in the other days, like I have 4 days starting from today, Friday, Saturday, Sunday, up to Monday. And we have 7 chapters. So we have chapter 12, chapter 13, 14, 15, 19. And the main chapters that we have here is a chapter 12 and chapter 16. So this is the biggest and largest and massive chapters with a lot of things that we talk in, because this is the introduction. So this is the introduction for particles. And this is the introduction for the rigid bodies. So what I would recommend is to divide your studies. Like, for example, we have 4 days starting from Friday to Monday. I would do like start studying these 2 chapters on Friday and these 2 chapters on Saturday. And then on Sunday and Monday, I will leave 18 and 19. So this is how I would do it. Divide them whatever, like maybe some of these chapters you managed to study them very well and others that you didn't study. So distribute them based on the weight of each one in terms of how much you understand each chapter. So this is how I would divide them. And while you are doing your revision, these are very big chapters. Like, I mean, if you look at the lectures, we have 30 hours on the channel here. So all these videos, and I'm sure that you will not be able to watch all of these videos again. So my recommendation is not watching the videos from start to end. Even if you made them 2x to shorten the time from 60 minutes to 30 minutes, it's still, you will have 15 hours to watch, which will make you overwhelmed. So my recommendation, maybe you watch the video that you are not watching very well, or some concepts that you didn't understand very well. So you go back to this video and watch it. So my recommendation is to go back to your notes and see what you have in your notes. Just like to see what did I do and how did I get this equation, how did I solve this problem? Because you know what? So this is all the materials. This is all the notes that I gave to you. So this is my notes that I was working from. And I'm pretty sure that 4 days is not enough to go through all your notes. So you go through each chapter very quick, like this chapter, like if you are studying 8 hours per day, so chapter 12 shouldn't take like more than 5 hours, and then chapter 13 shouldn't take like more than 3 hours, and see what you can do in 5 hours in terms of this chapter. Maybe for chapter 12, for example, I will give you an example here, like chapter 12, you will see what we did here. So like how did we derive the velocity from the position? So it's the time derivative of this one, and the acceleration is the time derivative of the velocity, or the s or VDVDS. So you will see these equations and you will see the integration form of these equations, like you have VDT and here is the S, and see all these equations. You should be sure when to use these equations, like when it's stated in the problem, something that triggers that you will have to use these equations, and how to use them, like how to substitute in these equations in terms of you are given a projectile problem, so you will think about X, Y, Cartesian coordinate systems. You are given like somebody's moving on a curved path, so like you will have to use a tangent normal. And something is moving on a circle, a body, so you will have to use r and theta. So that's what you want to make sure. So I'm assuming that you understand this chapter very well and you got a quiz on it and you solved some examples and some homeworks on these chapters, so you understand the concept. So all what you do is that you want to revise, and revisions needs a strategy because you are not studying from scratch. Studying from scratch, it will make you overwhelmed. And actually, I tried it before for one of my classes in my undergrad, and it didn't work. And especially for a class that as big as dynamics, I tried with fluid mechanics, and it was a very big subject, and I wasn't able to finish. And I get like my confidence level very, very down, and my anxiety was very high, and I got my worst grade. So dynamics is a very large subject, so you will need to have a strategy for the revision. And that's what I totally recommend you is to go through very quick. You might solve, like if we are talking about chapter 12, you might solve one problem on the velocity, acceleration, position. One maybe you look at the projectile problems with XY, and you have tangent normal and r theta. Maybe you solve one or two problems on this concept. And then for the relative motion, you may solve one problem. So you will end up with like solving 5 problems or something. And I'm talking about concept that you understand very well. So I'm not assuming that you didn't study chapter 12. If you didn't study chapter 12, it's a completely different story. So you have like 5 problems, maybe 10 problems max. And let's assume that you will spend like 6 hours on this subject in terms of revision and in terms of solving problems. So that's what I mean by revision. And you will do the same with the chapter 13, 14. And when you get chapter 16, it's another milestone because you are moving from particles to rigid bodies. So particles to rigid bodies, so you will have to understand the concepts of the rigid bodies very well. And it has a similar concept, like if you try to relate them to each other, you will have that velocity has something called, when we're talking about angular form, so it will be angular velocity, which will be d theta dt, the time rate of change of the angular position, and the acceleration, the opposite is alpha, which is the time rate of change of omega, or it's omega d omega ds. So you will have to check this concept and how to use them, and also they have some integration forms. And also there is relative velocities, so you will have to like manage to understand all these concepts. All right, so let's assume that you are done with the revisions from chapter 12, 13 up to chapter 19. I would leave the Tuesday, the day before the exam, for confidence, like, because if you were keeping solving problems and revise the chapter 19 at the last hour on Tuesday, at some point, oh, I forget chapter 12. I messed up. Like, I don't know how to understand, is this is a force problem or an energy problem or impulse momentum problem. So on Tuesday, you will like try to go through the old subject, solve the problems together. Like you don't solve the problems as specific to chapter 12. You pick a random problem from a textbook and solve this problem without know what is this problem belong to. Is it chapter 12 or chapter 15? So that's what you do here. You do general revision. It's just like you look on the entire syllabus, see how the chapter, maybe you look on the dynamics equation sheet and make yourself familiar with this sheet because it has everything. It has all the equations in each chapter. So while you are going through each chapter, look at the equations, know when to use and how to use each one of these equations. And then in the last day, make sure that you understand each one of these equations and how to use them, and then solve general problems. General problems. So that's my recommendation for Tuesday, is that you leave it, not study specific problems to each chapter, and start general revision, go through the syllabus and solve some problems. Maybe I post an exam, so you solve this exam this day so you can know where are you in terms of how you study very well for the final exam. So I would encourage you to studying every part, like don't leave anything, and start with the most important things and the things that you understand very well so you can get some confidence. And plan to finish the 7 chapters in these 4 days. So like don't leave everything to the last one day. Dynamics is a very, very big class. So you just like have to focus yourself and start early, don't start late. And if you are work or if you have any other commitment, just like try to make yourself free so you clear your mind and be ready for the exam. And try to be focused, both priorities, and knows that the priority in this class is a chapter 12 and chapter 16, and all the other chapters is just applications. So when you understand chapter 12, you will be able to understand 13, 14 up to 15, because just a few equations, if you like think about it, chapter 13, it's all about the Newtonian kinetics, sum of F equal to ma. And if you have a Cartesian coordinate system, you will have another 2 equation, tangent normal and r theta. So it will be very simple. Sum of fx equal to max, sum of fy equal to may. So it's as simple as that. And to solve this, you will have to draw a free body diagram and kinetic diagram. And I need to stress in this because what I saw in the midterm, that you guys don't draw, and with partial credit you are losing a lot of credit. I know that some students were able to draw a good free body diagram and kinetic diagram and got a lot of points, even if they didn't get the final answer very well. They messed up with some signs, they put different numbers, they forget some forces, but you still have some drawings to get points. So try to put as much drawings as you can, and for the entire class in chapter 13, chapter 17 and 18, and impulse and momentum, all of these requires a free body diagram. So I recall from the midterm exam, we have something like this. So all what you have to do is that you put the weight, the force of the weight, and you have a normal force perpendicular to the surface. You have friction force in this way. You have a P in this way. So you put all the forces. So this is free body diagram. So now you get 5 points on this, just the drawing, putting all the forces. And then you put the kinetic diagram. Yeah, like this body is moving this way, so we have here max, and choose the coordinate systems that makes your problem simple. Like don't put xy in this way. So you will end up with max and may. But if you did it in this way, you end up with only with one equation. So this is how I think this is the best way to like tackle any problem. And as I told you, the backbone of this class is a chapter 12, and all the other chapters are just applications. Like if you go back to the tangent normal, so the sum of the forces in the tangent equal ma tangent, sum of the forces in the normal direction ma normal. And this, I would expect you to use your dynamics equation sheet to get the a tangent. And the a tangent is equal to v dot. And if you know v, you can get the derivative of v and then get the tangent direction. Or it will be the R multiplied by alpha, because V is the R multiplied by omega. And similarly, if you want to go to the R theta, so the sum of the forces in the R direction is equal to MAR, the sum of the forces in the theta is equal to MA theta. And this means that you should understand how to draw a tangent normal coordinate system. You know that the tangent is always in the direction of the motion, the normal is perpendicular to the tangent, toward is the center of curvature, and the R and theta, so you should be able to know the these directions. And similarly, if you go to chapter 14, it's the work and energy. So it's just one equations or two equations. You know that T1 plus the sum of the all of the work from 1 to 2 is equal to T2. So that's how you keep yourself focused. Like, you know, this a chapter is all about this equations. This a chapter is all about all of these equations. So you will have to like manage a way to understand what is the equation belong for. And then when you understand this, when you solve the problem or what you have to do, what type of problem is this? Is it a kinetic energy? Is it like impulse momentum? Is it general Newtonian kinetics? And based on this, you will go to your dynamics sheets and bake the equations. And I saw some of you in the midterm, they didn't put anything in the partial credit, didn't put any equation. He wasn't able to recognize what type of problem is that. Maybe he recognized and he know that he will use these equations, but he didn't write it, so he didn't get any point. So all your thought process should be done in the partial credit pages that you will be going to submit. So that's totally my recommendation for the revision. And so be focused, put priorities, chapter 12, chapter 16, and then move from these. And then you should have a strategy to solve the exam. So as I told you, you need to get as much point as you can. So putting a strategy to solve an exam, so you have a problem, first you understand what is this problem belong for, and go to your dynamics equation sheet, put the equations, or don't put the equations now, maybe you draw a free body diagram and get some points, like you are collecting points. So first, number one, understand the problem very well. So you understand the problem very well. I mean, like maybe you are given some hints, some time, and you know when you are given time, you might use impulse momentum. So you are given forces and time. I said impulse momentum because I know that the impulse momentum equation has the integration of force dt. So I will use force and time. So what if it's given like forces and displacements or position or distance? So yeah, I know that I will use work and energy. Why? Because I know that the work is the force multiplied by delta S. So I have forces, I have displacement. So this is how you understand the problem very well. So you can know, sometimes it will be given directly, calculate the work exerted, calculate the total kinetic energy. So it will be known to you what problem you will use. And sometimes it will be given and you will be asked something else. So you will have to know which equations that you will be using. So this is about understanding the problem very well. Number two is do the necessary drawings. So necessary drawings, I mean a free body diagram, kinetic diagram, if you have like a very complex problems, like something like this, and you have a collar here, attach it to a spring, and there is maybe, okay, so you have to understand this problem, you know that this is moving on a curve, you might use tangent normal direction, so you will know that you will have a normal this way, and this is moving this way, you will have tangent, and then draw a free body diagram of this, putting all the forces. You will have weight is going down, you will have a spring. If a spring in this way, you moving this way, you might be, you have F friction, you have normal force coming from the base, and then you will draw another one for the free body diagram. So you will have the MA tangent is in this way, the MA normal is in this way, and then you will put the equations sum of F tangent equal MA tangent, sum of F normal equal MA normal. And then you get these from the free body diagram, and then you get these from the kinetic diagram. This from here and this from there. See all the forces that you have, and some them see which one in the tangent. Some of them might need to be analyzed and get the component in the tangent and the component in the normal. So you will have to do some work, but this is the start. Draw a free body diagram so you can have all the forces and make sure that you don't miss one. Do I have a spring? Do I have weight, friction, normal force? Make sure that you have all of these forces. If you have external force P, or like a cable that has a tension or something, so you have all the forces. And then look on the right hand side of the problem, you have A tangent, and you know that A tangent is dv dt. And you know that V is equal to omega R, so A tangent is alpha R. A normal, you know that A normal is V square over rho, or if you are not given V square, so you know that's it's omega square multiplied by rho. So that's how you solve the problems. Like, see what is given in the problem and then put it and draw it so you can see it in front of your eyes while you're solving the problem, and then substitute in the equations that you have, and then use the dynamics equation sheet. If you forget any of these, or you are not confident about your memorizing these equations, you look here and put the equations and try to solve. Don't leave the problem empty. Like, put your thought process. You will get credit. So this is the main tab. And also one another tip: don't be late for the exam. I also saw some of you guys start very late, like after 30 minutes of the exam, and didn't use their full time, and they write in the exam that I didn't got enough time, or I wasn't able. And like, start early, like make yourself clear your schedule, but wake up early. So we will have the exam during the time lecture 9:45. So make yourself like 9:45 at the exam time, that you are ready and can start the exam. So that's my main tips. And for revision, you don't have to study from scratch like you don't know anything, because this will take a lot of time. It will be very, very long revision. So just like to be clear, know what is, like, I assuming that you are following up with me all over the semester, solving the homeworks by yourself and understand the concept, and you got quizzed on all of these concepts, so you know what you are doing, like you know what you take. You are not starting from scratch. So if you are good on this, so start the revision by what I told you. Don't start from scratch. Put the main equations. Maybe you solve 5 to 10 problems on each one of these chapters to make yourself familiar and memorizing the strategies to solve the problem. And my tip is to keep the day before the exam clear for final revision. Like, you are done with the initial revision, and you will do final revision in the last day by going through the subjects one by one, and then maybe solving an exam to make yourself comfortable with the final exam. All right, does anybody have any question, any general question on these? Is this helpful?
Yeah, this is very helpful for me. I appreciate the walkthrough of the study.
Okay, thanks. All right, so I think I will give you guys some time, and also I will post some revisions from Dr. Dan Baker. I think he has good revisions. Maybe you will look on this, but I just like want to try to make sure that you study. Like I have been using this strategy since I was an undergrad, and it worked with me very well. Sometimes it get messed up with a lot of things, maybe because yeah, I was an undergrad student and I had a lot of things that I didn't study very well and get overwhelmed with many classes. But with this strategy, it allows me, it gives me to maximize the number of points that I can get from an exam. So this is what I totally encourage you. And when I messed up with this strategy and get overwhelmed with many things and starting from scratch because I don't feel confident with the concepts that I learned, it turns out that it makes me stressed. And in the exam, the problems that I know I wasn't able to solve. Like I wasn't able to solve the problems that I practiced very well because I was very distracted. So just like clear your mind and put the 4 days for the revision, and the final day is makes you confident. So this is that one that makes you confident. If you are confident in this day, you will enter the exam confident and start the solving the problem confidently because you are knowing the concept very well and you practiced and you did everything that you can do. So I think you will be good. So that's totally my advice, and I hope you guys that you will do great in the today's quiz and also in the final exam on Wednesday. And if you have any questions while you are studying for the exam, just email me. There's many of you are emailing me every day with questions in the homework, and I answer the emails in less than an hour. Sometimes it takes 2 hours, but I answer very quick. And if it's a big problem or things that's very hard to understand, just we can schedule a Zoom meeting and we can go through it together. Like you don't understand this concept very well and need somebody to show you how to solve a problem or walk you through an equation. So just email me and we can schedule a Zoom meeting and sit together and see how can we solve this problem or teach you how to understand this concept. Right, guys, good luck with your quiz. It will start in 3 minutes. You can stay here if you have any other questions, and I'm happy to answer them.
Thank you
Professor,
very much for. Oh, sorry.
all good. I don't see the quiz posted as upcoming.
Really?
Yeah,
Okay,
I just see homework 24 and 25.
okay, I will make sure it will show up in 10:15. Yeah, I will.
Okay.
Thanks.
Thank you for all the advice, Professor. Have a good day.